Welcome back to lesson 30, where we develop new techniques to find the area of a curve that is described in like a polar equation, and we also calculate not only the area surrounded by the polar equation, also we develop an equation to find the arc length of the polar equation. These are the 10 problems that we are going to solve. Let's go to start with the first one. But before starting, let's go to see a review of the area and of the arc length. And let's go to review the equation that we are going to use for area for polar equations. So when we have a polar equation, we have r of theta. R of theta maybe is the cardioid. Maybe r of theta is 2 times 1 minus cosine of theta. So maybe it's something like this. Is the cardioid. The r is from the center, and the theta is from the x-axis. So this is this point, this is the r, and this is the theta. Okay, this is r of theta. Let's say that I want to find the area that is inside, involved by this r of theta, this area. How I will do it? I will do it in the following way. I will imagine that I have a sector like this one. A pizza, almost like a pizza. So this pizza is going to be evaluated in polar coordinates, and we are going to find that the area of this pizza is, this is the r, the area is 1/2 r squared by dd theta. So the small area, this is dd theta, the small area that is here is almost like a triangle, is 1/2 the base r by the length, r by dd theta is the length. This is the term that we are going to analyze. Okay, so this is the area, the small area, and the total area is the sum of all the small areas. So the total area is the sum of 1/2 r squared dd theta from theta equal theta 1 to theta equal theta 2. We will see how to find the extreme values theta 1 and theta 2. So, first of all, let's go to see what is 1 radian. When you have a circumference like this one, you cover the length L through the radius r. This is the radius r. So the radius r is rotating an angle theta. When you rotate an angle theta, the relation that happens is that the length equal the length of the arc length is theta by r. How is this possible? So theta is L divided by r. So if theta is 1 radian, it means that this r is 1 meter and this L is 1 meter, in a way that 1 divided by 1 is 1. So when theta equal 1, if theta is equal 1, this means that L is equal 1 and the radius is equal 1. So 1 radians is the distance that you will travel if you travel 1 meter from here through a circle of radius of 1 meter. If you travel 1 meter, when you travel 1 meter, you have covered an angle that is 1 radian. And how much is in degree 1 radian? Around 57 degree, more or less. Of course, that you could walk through the radius of 2 meters through this distance, and this distance will be 2 meters, in a way that if you have here 1 radian will be 2 divided by 2. This 2 divided by 2. You see how consistent is this equation. When theta equal to pi, how much you have traveled? When theta equal to pi, you have covered one circumference. So it will be, the relation will be when theta equal to pi, here, when theta equal to pi, it will be L divided by R. So the length of a circumference is 2 pi r. Oh, we know that the length, the arc length of the circumference is 2 pi r. Okay, let's go to study relations. So once that you understand what it means angle, an angle means, an angle of 2 radians means that you walk 2 meters over the radius of 1 meter. This is what it means, 2 radians. And if you do it, the angle that you will cover, it will be more than 1 radian, it will be 2 radians, and it will be, the picture will be something like this. So you will walk another 1 meter, and you will walk another radians. 1 radian, 1 meter. 1 meter of radius. Okay, so let me erase this a little bit that I don't want here, and let me continue with what I want to tell you. So we have said that the length is the radius by the angle in radians. So the length of the arc length of the circumference when you move from here to here, you move a distance, a meters, an amount of meters that is the angle by the radius of the that you are performing. So what is the area of a pizza? What is the area of this small pizza? So you cover an angle theta. How you will do? You will do a relation that is density, is meter square by radians. Meter square by radian. So the total area, when you perform a circumference, the total area of the circumference divided by the total angle that you cover, the area divided by 2 pi, or the total area, pi r squared divided by 2 pi, have to be equal to the same density, the area that exists here per unit of angle, meter squared divided by radians. So what I want to find is the area A prime that is here. And this relation allow me to solve for the area A prime. What is the area A prime? If I solve it, the area A prime will be pi r squared divided by 2 pi by theta. So the pi will cancel with the pi, and their relation would say the area is 1/2 r squared by theta. Or, if you prefer, 1/2 instead of r squared, I will place r by r, that is r squared by d theta. So the small area, when the angle is a small d theta, is 1/2 r by r d theta. But r by d theta is ddl. Is the length is here. R by d theta, ddl, you see this relation, I will copy this relation, ddl the small distance that you will travel through the arc length will be r by d d theta. The r is constant, is the radius of the circumference. Okay, so as a result, what we have found is that the area of a pizza, of this small pizza, is 1/2 r squared by d d theta. The small area, dda prime, it will be 1/2 r squared by the small angle d d theta. And what will be the total area? The total area will be the sum of all the small area. So let's go to describe the area like this. The small area is 1/2 r of theta squared by d d theta. So the total area is the integral, is the sum of all the small areas. So whenever you have this polar equation, you are summing term like this: 1/2 r of theta squared by d d theta. And the sum of all the pieces, the sum of all the pizza, the sum is the total area. So the area will be the integral of 1/2 r squared of theta by d d theta. And this is the equation that we will use. And I hope that I have justified enough this equation. So let's go to do problems, but before doing problem, we need to develop another equation for the arc length. This is the area of a sector. This is the area of this sector. The area of this sector is 1/2 r squared by d d theta. And d d theta is here, this small angle. The total area, the sum of all the pieces. Now we are going to develop an equation to find this length, to make the sum of all the length of the cardioid. Wow. If you travel from here to here, how many meters will you advance? What is the length of this cardioid? This is another equation that we are going to develop. So let's go to develop the equation. So for the arc length, the equation that you will use is, you know who is r theta. Maybe r theta is the cardioid, 2 times 1 minus cosine of theta. So to find the length, the total length of the cardioid when you travel through the line, to find the total length, you will do a square root of r prime squared, so you make the derivative of this function, plus r squared, you make the square of this function. You make the square root of everything, and you integrate over d d theta, and you will say, wow, why this equation will work? Let's go to do a very, very simple formula, simple deduction. So d dx, x is r of theta cosine of theta. Y is r of theta sine of theta. So x depends of theta. So d dx will be the derivative of x respect to the theta multiplied by d d theta. And d dy will be the derivative of y respect to the theta multiplied by d d theta. And who is d ds squared? D ds squared, Pythagoras theorem, is d dx squared plus d dy squared. So d ds is d dx d dy. So d dx squared plus d dy squared is d ds squared. So I will substitute d dx. D dx is the derivative of x with respect to the theta by d d theta. So I put it ddx divided by dd theta square because it's ddx square. Dd theta square is here, is the dd theta square, plus ddy square. Ddy is the derivative of y respect to the theta square by dd theta square, that is here. So this expression is the expression of the arc length using polar equations. So what is ddx? dd theta. So the x is r cosine of theta. So ddx, the derivative of x with respect to the theta, is the derivative of the first r prime of theta multiplied by cosine of theta. R prime of theta multiplied by cosine of theta plus r of theta multiplied by the derivative of cosine of theta is the product rule. So cosine of theta, the derivative is minus sine of theta. So it will be minus r of theta sine of theta square. If we do the same thing by the derivative of y respect to the theta, you will find this expression, square by dd theta square. And if you keep going a little bit of algebra, you will find these three terms for doing the square of this, and you will find these three terms for doing the square of this. And the dd theta square will appear here, but when you sum this with this, it will be r prime squared cosine square of theta plus r prime squared sine square of theta. Factor common r prime square, and you factor common cosine square of theta plus sine square of theta with this 1, it will appear r prime square. When you do the sum here, it will be r squared cos the same thing. It will appear r squared by dd theta square. As a conclusion, we have that the DDS is the square root, DDS squared, DDS is the square root of the derivative of r prime of theta square plus r squared dd theta. And S is the integral of this expression. The S is the sum of all the DDS. So the sum of all DDS is the integral of DDS. And this is the S. So this is the equation that we are going to use. Once that we have finished, let's go to do the problems. I'm sorry, but I have to justify completely the two equations that we are going to use. One for the arc length, the other one for the area, which is 1/2 r squared of theta dd theta, the integral from theta 1 to theta 2. Let's go to use in this lesson these two equations. Problem 1. Problem 1 say find the area of the region bounded by r of theta equal 3 cosine of theta. If you go to this page, open Omnia, and you represent 3 cosine of theta, it will give you a circle in Cartesian coordinates. So the circle have a radius, and the radius have a center. The center is 1.5. And how you will change this to the Cartesian coordinate? Well, you see the previous lesson, and there is a very similar problem when you complete the squared and you find the equation in Cartesian coordinates of a circle of radius 3/2 in this case, center at this point, 3/2, 0. You do it and you will find this. So this page is an interesting page because it allows you to plot the graph of the functions in polar coordinates. So what is our equation? Our equation says that the area is 1/2 the integral from theta 1 to theta 2 of r of square of theta by dd theta. So plug in the r. If I plug in the r is 3 cosine of theta, so the r squared is 9 cosine square of theta. So you plug in the r, and you make the integral. The integral is not a problem. It's the integral of 9 cosine square of theta, using the identity that cosine square of theta is 1 plus cosine of the double angle 2 theta divided by 2. You can perform this integral. Now the subtle thing here is to see this limit of integration. I'm going to show you how to find these limits of integration. So the result will be that the total area will be 9 pi divided by 4 in some units. This integral is very easy, 1/2. The 2 will come here, 9/4, and the integral of d theta will be theta, and the integral of cosine of 2 theta is sine of 2 theta. Okay, the integral is not a problem. What we have to pay attention is to the lower is from theta equals 0 to theta equal pi. So let's go to do it. So I repeat, the equation that we will use is the area is 1/2 r squared d theta. What I have done is to plug in r squared on my equation and to make the integral. The integral, as I said, is not the problem. How we will find the limits of integration? To find the limits of integration, I suggest you to do like this. The equation that you have, if r of theta equals 3 cosine of theta. Okay, the theta starts here. The r is this distance, and the theta is this angle. This angle is varying. When you move, the angle varies. Now the angle is 0 when it is here. Now the angle is negative, negative, negative. It seems to me that it starts the angle at pi divided by 2. And it ends at 3 pi divided by 2. When you go through the cardioid, the angle is varying, starting at r equals 0, is varying from theta equal pi divided by 2 to theta equal minus pi divided by 2. Wow, it will be the same thing that this thing. Let's go to do it. Let's say here from 0 to pi. Let's go to do it. So, so when r is 0, if r is 0, then 3 cosine of theta is 0, then cosine of theta is 0, then theta equal pi divided by 2, or theta equal 3 pi divided by 2. So I will do this integral. The area is the integral from theta equal pi divided by 2 to theta equal 3 pi divided by 2 of r squared of theta d theta. This is the integral from theta equal pi divided by 2 to 3 pi divided by 2 of r squared, but r is 3 cosine of theta. So it will be 9 cosine squared of theta d theta. And using this identity relation from of cosine squared of theta, from theta equal pi divided by 2 to 3 pi divided by 2 is 9. And instead of writing cosine squared of theta, I will write 1 plus cosine of 2 theta divided by 2. This is the trick to solve this integral d theta. And now if I solve this integral, it will be 9/2 goes here, 9/2, the integral from pi divided by 2 to 3 pi divided by 2 of 1 plus cosine of 2 theta d theta. So it will be 9 half, open parenthesis. What is the integral of of 1? 1 by d theta, the integral is theta. What is the integral of cosine of theta? What is the antiderivative of cosine of theta? Well, sine of theta, sine of theta, sine of 2 theta, the derivative is cosine of 2 theta multiplied by 2. So 1 half of sine of 2 theta is the integral of cosine of 2 theta, because the derivative of sine of 2 theta is cosine of 2 theta multiplied by 2. So because it doesn't have any 2, I will divide by 2, and now the derivative will be okay. Now I have to evaluate this equation, this result, from pi divided by 2 to 3 pi divided by 2. So it would be 9 half, theta is 3 pi divided by 2, plus 1 half sine of 3 pi divided by 2, 2 times of 3 pi, minus, open parenthesis, minus the evaluation at theta equal pi divided by 2. So it will be pi divided by 2 plus 1 half of sine of 2 theta, of 2 pi divided by 2 of pi. What is sine of 3 pi? Sine of 1 pi is 0, of 2 pi is 0, of 3 pi is 0. So this is 0 and this is 0. So the result would be 9 half, that multiply 3 pi divided by 2 minus pi divided by 2. So it would be 9 half. What is 3 pi divided by 2 minus 2 pi divided by minus pi divided by 2 is 2 pi divided by 2. Okay, if you take 3 times pi divided by 2 and you take 1, you subtract 1 pi divided by 2, you will be ending with 2 pi divided by 2. So the 2 will cancel with the 2, and the result will be 9 half of pi. Okay, is this the same result that is here? Let me see. 9 half of pi? No. Why? Why? Because I forgot 1 half here. It's 1 half r squared d theta. It's 1 half, and this 1 half, I have to put it here. 1 half, and now it will be the same result, 9/4 of pi. And let me check if it's the same result that is say here, 9/4 of pi. Okay, so we have found the area that is here. Can we check if the area is correct? Yes, of course. This area is the area of a circle. The circle, I see that it has the radius. What radius it have? It has the radius 3 half. 3 half because this is the center, and the radius I see that is 1.5, 3 half. So the area should be pi r squared. So the area should be pi, but r is 3 half squared. So the area will be 9/4 of pi. Is this the same result that I found here? Let me check. 9/4 of pi. Yes, is the same result. So everything is consistent. Let's go to the next problem. Now, this problem it say, verify that the area bounded by 1 petal of the rose curve. Wow, the rose curve. R of theta equals 3 cosine of 3 theta. So I'll go to my programs to save times, to graph, to plot this equation. And it say the 1 it say verify that they are bounded by one petal of the rose curve. This is the rose curve. This is the rose curve. It has 3 petals. So it says that find the area of one petal. One petal is here. How I will find this area? Well, the area is 1/2. I don't want to forget the 1/2. The integral of r squared d theta. The r of theta, I know what it is. The area is 1/2 the integral of 3/9 cosine squared of 3 theta d theta. So the problem here is not to do this integral, which is not difficult to do, very easy to do. It's the same technique that we use on the last problem, that is to write cosine squared of 3 theta like 1 plus cosine of the double angle 6 theta divided by 2. So doing this integral means doing this substitution. You substitute cosine squared of 3 theta by this expression, and it will be very easy to find the integral. The key question here is to find the limits of integration. Here they say that the limits of integration is from minus pi divided by 6 to pi divided by 6. It looks that minus pi divided by 6 is this angle, and pi divided by 6 is this angle. But how I can be sure that these angles are the correct angles? So we'll do like this. We say when r is equal 0, so the r of theta that I have is r of theta equal 3 cosine of 3 theta. 3 cosine of 3 theta. If r is 0, means that 3 cosine of 3 theta is 0. It means that cosine of 3 theta equals 0. And now comes the question, for which theta cosine of 3 theta is equal 0. To help you to find the theta for which cosine of 3 theta is equal 0, we represent the function cosine of 3 theta. Remember, cosine of theta is a function that oscillates one time over the interval from 0 to 2 pi, while cosine of 3 theta is the function that will oscillate 3 times in the interval from 0 to 2 pi. So it will have more zeros than cosine of theta. So we go to the graph of cosine of 3 theta. And this is the graph of cosine of 3 theta. Let's go to right here, cosine of 3 theta, cosine of 3 theta. This is pi, and this is minus pi. So I need to find the first cutting place. Here is when it's 0 cosine, and here is when it's 0 cosine. So this is pi, so it means that if this is pi, how I will find these points, these 2 points. Looking at the graph, we see that if this is pi, this is one part, you see, from the top to the 0, from the 0 to the bottom, from the bottom to the 0, from the 0 to the top, from the top to the 0, from the 0 to the bottom. So it seems that this, if this is pi, this is pi divided by 6, pi divided by 6, 2 pi divided by 6, 3 pi divided by 6, 4 pi divided by 6, 5 pi divided by 6, 6 pi divided by 6 of pi. So this is pi divided by 6 and this is minus pi divided by 6. So the first petal of this polar function is when you integrate from minus pi divided by 6 to plus pi divided by 6. And now you do the integral, and when you do the integral, you will find 3 pi divided by 4. Okay, and the problem is done. We can check. If I plug in theta equal pi divided by 6, it will be true that cosine of 3 theta or cosine of 3 times pi divided by 6 will be 0. Well, this is cosine of pi divided by 2, because 3 pi divided by 6 is pi divided by 2, and cosine of pi divided by 2 is 0, so it's true. So the problem is solved. Not easy not to do the integral. The integral is easy. To find the limits of integration. Okay, let's go to the next problem. Now we go to problem 3. Problem 3 says, find the area of one petal of the rose curve r equal 4 times sine of 3 theta. If you go to your plotting software, you will find that 4 times sine of 3 theta have 3 petals. Is this one. And the problem says find the area of this petal, of one of them. There are asymmetries, so the area of each one is the same one. Okay, I see that the angle for this petal, the angle varies from theta equals 0 to theta something, but I don't know. The problem here is to find the interval, the limits of integration. From which theta? From theta equals 0 to theta equal, apparently, the problem says here that theta is pi divided by 3. Let's go to find this theta equal pi divided by 3. Okay. At the point r equals 0 is when the object, remember that the function is doing like this. It goes to the 0. The theta is changing. Remember that this is the r, and this is the theta. The theta is changing, and it comes back to the 0 again. So when it's 0, there are many values for theta. So this is the challenge, to find this value. So the r of theta is 4 times sine of 3 theta. For sure, the challenge is not to plug in r squared dd theta. 1/2 r squared dd theta is the area, and the challenge is not to do the integral. Also, the challenge is to see clearly this 0 and pi divided by 3. Let's go to do it. R of theta is 4 times sine of 3 theta. If r is 0, because if you imagine the function passed through r equals 0 one time, 2 times, 3 times, 4 times. It passed through r equals 0 4 times. Wow. So when r of theta is 0, if r is 0, is because sine of 3 theta is 0. If sine of 3 theta is 0, is because 3 theta should be 0 or pi or 2 pi or 3 pi or 4 pi or 5 pi or whatever you can imagine. If you go again and again, round it, you will find many thetas. So the one that we have to find is the first, for the first petal. So if 3 theta is 0, is because theta is 0. If 3 theta is pi, is because theta is pi divided by 3. If 3 theta is 2 pi, is because theta is 2 pi divided by 3. So between 0 and pi divided by 3 occur the first petal. So I need to integrate from 0 to pi divided by 3. And this integration is not difficult. It's from 0, theta equals 0 to theta equals pi divided by 3. And this integration, you see it. And what is saying that this area, the value of this area is 4 pi divided by 3. So the total value of the 3 petals is 4 pi. Okay. The other thing that you can do maybe also is to draw sine of 3 theta. If you draw sine of 3 theta, you would see that pi is here, pi. Here is pi. So you divide, this is sine of 3 theta, so you divide 0 to pi, you divide in 6 parts. 1, 2, 3, 4, 5, and 6. So this is pi divided by 6. This is 2 pi divided by 6. This is 3 pi divided by 6. This is 4 pi divided by 6, etc. And when the function becomes 0, here r is 0, and here is 2 pi divided by 6, that is pi divided by 3. So the first petal is generated between these two angles, between 0 and pi divided by 3, or 2 pi divided by 6. Okay, so the problem is solved. Let's go to the next one. Okay, let's go to do problem 4. Problem 4 say they give you the polar equation r of theta equal 1 plus 2 sine of cosine, 2 times cosine of theta. And they ask you find the area of the inner loop. If you represent this function, it will be, this is not the cycloid, this is the leverage. It has a name. I'm sorry that I don't remember the name. This is the representation that if you go to the web page that I give you, you will find this representation. When you stop at this point, you are stopping at the point r equals 0. When r equals 0, theta takes some values. So the inner loop is made from the points when theta equals 0. So I need to find the limits of integration. This is what is the difficult thing here. So the area is 1/2 r squared dd theta. So how I will do? I will see that when r equals 0, so 1/2 r squared is here, dd theta. The problem is not doing the integral. The problem is to find this interval of these two limits of integration. Let's go to find these two limits of integration. So when r of theta is 0, when r of theta is 0 is when you are here. When you are here, as soon as theta grows, you will go here, and then again the r will be 0 again. So I need to find the two thetas for which this inner loop is generated when r is equal 0. Which one are the two thetas? So I would say, if r of theta is 1 plus 2 times cosine of theta, if r is 0, it's because 1 plus 2 times cosine of theta is 0. So it means that 2 times cosine of theta is minus 1. It means that cosine of theta is minus 1/2. And it means that cosine of theta should be pi minus pi divided by 3, or pi plus pi divided by 3. So the 2 points where the cosine of theta is minus 1/2, this is minus 1/2, is when theta equal pi minus pi divided by 3, or theta equal pi divided by plus pi divided by 3. At these 2 points, cosine of this and cosine of this is minus 1/2. Okay, so pi minus pi divided by 3 is 2 pi divided by 3. And pi plus pi divided by 3 is 4 pi divided by 3. So now we set up the integral. The area of this inner loop is the integral from 2 pi divided by 3 to 4 pi divided by 3 of r squared. R squared is 1 plus 2 cosine of theta squared d theta 1/2. If you make the integral, you should find for pi divided by 3, you should find the same result. I think that here they say from 2 pi divided by 3 to pi, but they multiply by 2. So it should be the same that doing the integral from 2 pi divided by 3 to 4 pi divided by 3 at once. Okay, so this is the result. Let's go to the next problem. So the next problem says find the length of the polar curve r equal 8. R equal 8 is the circumference centered at 0 with a radius 8. Is the set of points where r is equal 8. So the equation should be x squared plus y squared equal 8 squared. So this should be the equation. And the problem is say, find the length. The length. If you walk from here around the circle, how many meters you will walk? Well, I know you will borrow the length, the arc length, 2 pi by 8. So you will walk 16 pi. And this is the result, but the problem is asking you to do it in polar with the polar equation. So the area will be a 1/2 the integral of r squared r of theta squared by d theta. And d theta is from 0 to 2 pi in this case, because theta varies from 0 to 2 pi, so the area will be 1/2 the integral from 0 to 2 pi of r squared. R is 8 squared d theta, so it will be 1/2 8 squared by d theta by the integral of d theta from 0 to 2 pi, so it will be 1/2 8 squared multiplied by 2 pi. So this 2 will cancel with this 2. 8 by 8 is 64 pi. So what is happening here? Why I'm not having the correct result for the because the area of the circle, the area is pi r squared, so it's pi 8 squared 64 pi. So the area is correct. So what it's asking me is not big for the area. It's asking me for the length. The length is 16 pi. So I have to use the equation for the length in polar, the polar equation for the length. And the polar equation for the length is here. The S, the length, the arc length is, let me put it more smaller, the arc length is r squared plus the derivative of respect to the theta squared d theta. This is the equation that we see at the beginning of this lesson. Who is r squared? 8. What is 8 squared? 64. What is the derivative of r respect to the theta? Well, r doesn't depend of theta, because r is a constant, is 8, so the derivative of r respect to the theta is 0. So you make the integration, 64 is 8, the square root, 8, the integral of d theta is theta, so 8 a multiplied by theta, evaluate between 2 pi and 0, it would be 16 pi. And the problem is solved, and of course it gives you the same 60 pi. Sorry that I was calculating area again, but the problem is about the arc length, the length of the polar curve. Okay, let's go to the next. The next problem is about the length of a polar curve. Now, the polar curve is 4 cosine of theta. If you represent 4 cosine of theta, it would be this graph. You can use my program for cosine of theta. It will give you this graph. Or you can also, if you remember, we did it. If you multiply by r, so you will have r squared equal 4r cosine of theta. But r cosine of theta is the x, so you will have an equation that says for x equal x squared plus y squared, and if you find plus y squared equals 0, so if you complete the square here on the x, you will find the equation of the Cartesian equation of this curve, of this polar curve. Okay, I'm not going to do it, but clearly the Cartesian equation is x minus 2 x minus 2 squared plus y squared equal 2 squared. If you complete the square here, you will find this equation. Okay, and now what is the problem? The problem says find the length of the polar curve. The length, it means about how many meters have this length. Well, I know it has 2 pi r. The length should be 2 pi r. So it should be 2 pi because r is 2. The length should be 4 pi. But the problem says find it using our equation for polar. The polar equation to find the length. So the polar equation to find the length is r squared plus the derivative of r respect to the theta is square dd theta. Who is r of theta? R of theta is a circle of radius 2. You can check that, r of theta is here, r of theta is 4 cosine of theta, so the r squared is 16 cosine squared of theta, and the derivative of r respect to the theta is minus 4 sine of theta. Plugging this into the equation, you will find 16 sine squared of theta. So taking common factor 16, it will be 16 that multiplies sine squared of theta plus cosine squared of theta, which is 1. So square root of 16 is 4. So it will be 4 multiplied by the integral of dd theta. And now the limit of integration. The limit of integration are from 0 to pi, because to generate this circle, you start here, and the angle vary at r equals 0. You come back to r equals 0 2 times. So let's go to do it. R of theta is equal 4 cosine of theta. 4 cosine of theta. 4 cosine of theta. So when if r is 0, means that 4 cosine of theta is 0. It means that cosine of theta is 0. It means that theta vary when cosine of theta is 0. Cosine of theta is 0 between pi divided by 2 and when theta is 3 pi divided by 2. So the width between pi divided by 2 and 3 pi divided by 2 is pi. So if I do the integral from theta 1 to theta 2, should be the same thing, because the whites of this from 3 pi divided by 2 minus pi divided by 2. This is pi. So the integral should be the same thing for pi. And the problem is solved. So the theta vary from 0 to pi, or if you prefer, vary from pi divided by 2 to 3 pi divided by 2. Making this variation of the angle theta starting here, if you start here at the 0, you start with the angle plus pi divided by 2. So you go down, 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 down. You go down with the angle. So the angle is here. So initially was here, pi divided by 2. And finally was, you see, the angle was here, when you are here, was here, or when you approach to the 0, when you approach here to r equals 0, the angle is minus pi divided by 2. So again, another representation that you can do is that theta vary, theta 1 start at pi divided by 2, and theta final ends at minus pi divided by 2. And again, theta 2 minus theta 1 will be pi. Will be minus pi. But the width will be the same thing. Okay, so this is the arc length. And let's go to another. Set up the integral for the arc length of the curve r equal to theta. The curve r equal to theta is here, and it is not complete the graph. Let me put the graph complete. Okay, this is the complete graph. So the curve does like this, and the challenge is to find the arc length of this curve in polar coordinate r of theta. How many meters you have here? If you walk here, how many meters you will walk around this curve? It's not a circle, it's the graph r of theta equal to theta. And theta vary from 0 to 2 pi. So we plug in numbers. So the equation is r squared plus the derivative of respect to the theta squared, dd theta. So we need to do the integral from 0 to 2 pi. If we do the integral of 0 to 2 pi, square root of r squared, r is 2 theta, so r squared is 4 theta squared. The derivative of r respect to the theta is the 2, so 2 squared is 4 dd theta. If you do this integral, it will be around 42.50. Okay, let's go to the next problem. Okay, this problem asks you to use a graphing utility. So they give you a polar equation. This is the polar equation. 6 divided by 3 minus sine of theta. What represents this polar equation? This polar equation represents an ellipse. Always that you have an equation in this form. R of theta equal something epsilon by d, something in the numerator. In this case, epsilon by d. It could be the 6, but it's not the 6. I explain you why. So the form of an ellipse, the polar equation for an ellipse is epsilon by d divided by 1 minus epsilon by sine of theta. Any polar equation of this form, maybe with sine of theta here or cosine of theta here, maybe with minus or plus, doesn't matter, the four combination, minus, plus, sine of theta, cosine of theta, all of them represent an ellipse. How I will compare this equation with this equation, I need to get a 1 here. So I will divide by 3 the whole equation. If I divide by 3, 6 divided by 3 is the 2, 3 divided by 3 is the 1, so I got the 1. 1 that is here, 1 sine of theta, divided by 3 is 1/3. So now I can compare this equation that have the 1 with this equation that represent the polar representation of an ellipse. So now I can compare the epsilon by d is the 2. And the epsilon is what is next to the sine of theta, so it's 1/3. From this equation, have epsilon equal 1/3, and v, the directrix, is 6. So what is happening here, that wherever you have a equation like this, that is a general equation for hyperbolas, for ellipse, for parabolas, when this is a parabola, the epsilon is 1. When it's an ellipse, the epsilon is between 0 and 1. In this case, it's an ellipse because epsilon is between 0 and 1, is 1/3. So if you plug in your graphing utility this equation, you will have the ellipse. What is the focus of the ellipse? I suppose that is something here, and the other focus is something here. So the distance from here, this distance plus this distance is the same whatever point you catch. So this distance plus this distance is the same as 2a, is equal to 2 to this distance. This is 2a. Okay, so what? So what is asking the problem? Use a graphic utility to obtain the S. Oh, the S is the integral from 0 to 2 pi of a square root of r squared of theta plus the derivative of r respect to the theta square dd theta. So we need to plug in the equation here. The r squared could be this one, or could be the same one, this one. Is the same thing. So the question here is that you will not be able to do the integral. So you will have to use an approximation for this integral. So this integral, they are named elliptical integral, and they are difficult to solve. So this is 6 divided by 3 minus sine of theta squared plus the derivative of r respect to the theta. So r of theta is equal to 6 divided by 3 minus sine of theta. So the derivative of r respect to the theta is the derivative of the numerator, which is 0, by the denominator, 0, minus the derivative of the denominator. The derivative of the denominator is minus cosine of theta, divided by the denominator square, 3 minus sine of theta square. So I will plug in here a square, the derivative of r respect to the theta square. So the minus sign will not affect, because when I do it the square, it will be positive. So a square, and everything square by dd theta. And this integral is difficult to solve. So you use a graphing utility, and the length of this ellipse, if you walk through the ellipse, this is not a circle, so it's not 2 pi by r. If you walk through the ellipse, the total length of this ellipse will be, using a graphing utility, will be 13.736. And this is the problem. Let's go to the next one. Okay, the next one say what it represents, this conic equation, this polar equation. What conic it represents? It represents an ellipse, it represents a parabola, it represents an hyperbola. What represents the equation 2 times sine of theta plus 3 times cosine of theta. So what we will do, we will multiply by r both sides of the equation. If we multiply by r, you will obtain r squared in the left side of the equation. You will obtain 2r sine of theta and 3r cosine of theta, but you remember that r sine of theta is the is the y. R sine of theta is the y, and r cosine of theta is the x. So it will appear 2y plus 3x. 2y plus 3x. But we know that r squared is x squared plus y squared. What we have done is to get rid of the r and the theta in this equation, and we, by certain trick, multiplied by r, we have passed from a polar equation to a Cartesian equation where it appears only the x and the y. Now, the second problem is to complete the square. So if you complete the square, that you know how to do it, the equation will be a circle. And the circle will have the radius 13, radius square will be 13 divided by 4. And the circle will have the points, the center of the circle will be 3/2 and 1. X equals 3/2 and 1, and we have finished this lesson. Heavy lesson. I'm sorry, heavy lesson. I'll see you on class.